So in our last lecture series, we discussed about the pulley problem, and in this lecture, what we'll do is we'll try to understand this pulley problem from another point of view. Okay. So consider the mass m2. If the mass m2 freely falls, if the mass m2 is allowed to fall freely, then you all know that the mass m2 will fall with an acceleration g, which is acceleration due to gravity, and the weight which is responsible for this acceleration due to gravity, I mean the force which is responsible for this acceleration is gravity, is the weight of the mass m2, which is m2g. Agreed? But in this case, what you see is m2 is not freely falling, and it is falling with an acceleration less than g, that is falling with an acceleration a. It means since m2 is not freely falling, it means there is a force. Okay, that is one way to understand equations. So if m2 would have fall freely, then you could have written m2g, but m2 is not falling freely because m2 is actually falling with an acceleration a. So when you know that something is not freely falling, then you be damn sure that there is some force which is obstructing the free fall, and that you write it as tension. So this is another view of making the pulley equation. This view will make tough pulley problems simpler. Let us look at m1. So m1 is going up with an acceleration a. So since m1 is going up with an acceleration a, there must be some force that is taking m1 up, and that force is somehow getting little bit hindrance from the weight of m1 itself. So t minus m1g, and this final force is making m1 move with an acceleration a in the upward direction. So this is one way of making equation. Once these equations are made, then you can easily solve any problem. Let us solve one more problem related to pulley. Agreed? So consider you have a block here, and from here a wire goes, and then you have a pulley over which the wire is going. Okay, and then you have another block attached to this pulley. Agreed? Now consider now that this block that is at the top has a mass m1, and this block has mass m2. You can see that m2 is greater than m1, hence you already know that it is going to fall downward. But can you tell me, is m2 going to fall freely? No, because there is some string tied to a mass m1, so it is not going to fall freely. So when it is not going to fall freely, it means it will fall with some acceleration a, and I can write the net force which is causing m2 fall is m2a. But there is another way to calculate the net force. What is the force with which m2 want to fall? See, m2 wants to fall freely with its own weight, with acceleration due to gravity. But since it is attached with m1, that is an upward force that is creating some problem in the life of m2, and that upward force is tension T. So this is the first equation that we got created. So you see, m2 will not have free fall. m2 will not feel it's having free fall. m2 will feel it is falling under some force that is obstructing its free fall. For example, if I throw you off a building, you will have a free fall. But when you are going down using a lift, it means you are not having a free fall. You are going down using a lift with some acceleration a, because the lift is not allowing you to have the free fall. Similarly, the work of the lift is done by the string here. Look at mass m1. You know that mass m1 is going forward, and it has to go forward with an acceleration a, the same acceleration a with which m2 is going downward. Why? Because m1 and m2 are now connected. They are one part, they are one system now. You cannot have m1 and m2 go with different acceleration, that will break the string. So what is the equation for m1? Now it's interesting. You see, m1 is on the floor, and this floor is frictionless, and interestingly, there is no weight which is obstructing the tension. The tension is now acting independently. Hence, I can say that you already know that the m1 is moving with an acceleration a. So you can happily write m1a. But this motion in m1 is actually created by m2. And how to write that motion? You know that the presence of m2 has to be indirectly written in terms of force, and that is the tension. So I can write finally the equation as tension equals to m1a. So these are the two equations for this type of pulley system. Now when you solve this, you know how to easily solve this. You get the tension T as m1 m2 g m1 into m2 divided by m1 plus m2. Now an interesting thing. You remembered what was the tension in our last example? The tension in this example? The tension in this example was twice m1 m2. Okay, there was a number 2 apart from m1 m2 divided by m1 plus m2 g. Agreed? Now look at this interesting thing. The interesting thing that I want to discuss here is that in both the cases, in both case A, so consider this is case A and consider this is case B. In both the cases, the tension is almost same, just that in the first case we have an extra 2 factor. This means that the tension that is created here, so consider the tension created in case B is less than the tension which is created in case A. Is this obvious to you? It has to be. The tension in case B is obviously less than the tension in case A, because in case A, the extra weight of M1 was also helping an increase in tension. So the both M2G and M1G were creating tension in the rope. But here, only the M2G is responsible for creating tension in the rope. Hence, in this case, we don't have a two factor. Agreed? So now in the next lecture, what we'll do is we'll hang our pulley in a lift, and then we'll see how we can easily make the free body diagram without much effort. That we'll do in the next class.